Hello everyone. This is Diya Saha Choudhury from Electronics and Communication Engineering Department from third year, and I have got the topic AM transmitter block diagram and working. This is my CA1 assignment, and let's get started. So here we have AM transmitter and its types, block diagram of high level AM transmitter, working of high level AM transmitter, the Q point of various amplifier classes, block diagram of low level AM transmitter, working of low level AM transmitter, low and high level transmission efficiency, and an example problem to understand it more clearly. So, in AM transmitter, let us understand what is AM transmitter, where is it used, and how does it work. So, basically, what is meant by AM transmitter? AM transmitter takes the audio signal as an input and delivers amplitude modulated wave to the antenna as an output to be transmitted. The AM transmitter working is very simple. The amplitude modulated transmitter produces an electromagnetic carrier wave whose amplitude is modulated, varying at an audio rate and which travels to the other to a radio receiver. Let's see, where is an AM transmitter used? Transmitters that transmit AM signals are known as basically AM transmitters. So these transmitters are used in medium wave and short wave. Medium wave is MW and short wave is SW. Frequency bands for AM broadcast. So the MW band has frequencies ranging from between 550 kilohertz to around 1600 kilohertz, and the SW band has frequencies ranging from 3 megahertz to around 30 megahertz, we can say. So, AM transmitter has two processes. One is a modulation process that we all know, and the second is in which the to raise the power level of a modulating signal. This process in turn gives the effective radiation. So, based on those two processes, the AM transmitter is divided into two levels. That is the high level and the low level. Now, one more thing that we have to know is, let us say this is the message signal, this is a multiply sign. Here we have cos omega ct, and this gives us the transmitting signal. So, from the block diagram, we can understand much more clearly. Let us take, this is A, this is B, this is D, this is E, and this is C. So, like we said, this multiply sign over here, this is the modulated class C amplifier. This is the multiply sign. And this whole thing over here is the message signal, MT. And this thing over here that comes from the mic is the transmitting signal. And this is the cos omega ct. And from here we get the transmitting signal. I hope it's clear. So basically, there is also a drawback of AM transmitter, that is in low level. That is poor efficiency is obtained in class B amplifier, and there is also a distorted wave. So these two drawbacks are of low level modulation signal. Other than that, the various sections of the figure here we have is carrier oscillator, buffer amplifier, frequency multiplier, power amplifier, audio chain, modulated class C power amplifier. So, what is a carrier oscillator? In short, we can say that the oscillator is usually the first stage of any transmitter. We know this. And its job is basically to create a radio frequency carrier that can be amplified and modulated before being sent to the transmitting antenna. So the frequency multiplier stage then increases the frequency of the carrier to its requirements. Basically, it is the frequency of the carrier is always high because it is very difficult to generate high frequencies with good frequency statement. Buffer amplifier. Next, we have the buffer amplifier. A buffer amplifier is the one that provides electrical impedance transformation from one circuit to another with the aim of preventing the signal source from being affected by whatever currents or voltages for a buffer that the load may influence. The frequency multiplier. The frequency multipliers are devices that generate an output signal of which the output frequency is a multiple or harmonic of its input frequency. And the power amplifier, the power of the carrier signal is then amplified in the power amplifier stage. This is the basic requirement of high-level transmitter. A Class C power amplifier gives high power current pulses of the carrier signal at its output. Audio chain, the audio chain to be transmitted is obtained from the microphone. That is the mic, like we have in this figure. This is the audio channel. The audio driver amplifier amplifies the voltage of the signal. The amplification is necessary to drive the audio power amplifier. Next, a Class A or Class B power amplifier amplifies the power of the modulated signal. Modulated Class C amplifier. This is the output stage of the transmitter. The modulation process that we have stated beforehand. It is it is always taking place in this modulated Class C amplifier. So basically, the working of high-level transmitter is not very much different to that of a low-level transmitter. Still, let us understand how does it work. Basically, the difference in high-level transmitter is where the modulation takes place. Instead of adding modulation immediately after buffering, this type of transmitter applies the unmodulated RF carrier signal first. Thus, the signals at points A, B, and D are the unmodulated RF carrier waves. A, B, and D are the unmodulated RF carrier waves. And the only difference is that they become bigger in voltage and current as they approach the point D. So, this is how the working takes place. And the final power amplifier does double duty in a high level transmitter. First, it provides power gain for the RF carrier signal just like the RF power amplifier did in the low level transmitter. In addition to providing power gain, the final PA also performs the task of modulation. If we have guessed that the RF power amplifier operates in a nonlinear class, then we are right. Classes A and B are considered linear amplifier classes. The final power amplifier is a high-level transmitter which operates usually in class C, which is a highly nonlinear amplifier class. Also, the Q point of various amplifier classes is shown here. So, let us come back to the block diagram of low-level AM transmitter. Here we have the RF carrier oscillator, the buffer amplifier, then the modulator, the RF power amplifier, the mic here gives the AF voltage amplifier which then connects to the modulator. This These all in turn go to antenna coupler and then we get the transmitter signal. There are two signal paths in a transmitter: low level transmitter, audio frequency AF and radio frequency RF. The RF signal is created in the RF carrier oscillator. At test point A, the oscillator's output signal is present. The output of the carrier oscillator is a fairly small AC voltage, maybe perhaps from 200 to 400 RMS. The oscillator is a critical stage in any transmitter. It must produce what we call an steady and an accurate frequency. We might recall that every radio station is assigned a different carrier frequency. The dial or display of a receiver displace the carrier frequency. If the oscillator drifts off frequency, the receiver will be unable to receive the transmitted signal without being readjusted. Worse, if the oscillator drifts into the frequency being used by another radio station, interference mode. This is very much desirable. Two circuit techniques are commonly used to stabilize the oscillator. Number one is the buffering, and number two is the voltage regulation. Here we have the voltage regulation for oscillator stage, and then we have the buffer amplifier. So, in voltage regulation, the supply voltage to the oscillator is regulated at a constant value. The regulated voltage is often around between 5 and 9 volts. Zener diodes and three terminal regular ICs are commonly used voltage regulators. As the battery discharges, its terminal voltage falls. The DC supply voltage in a car can be anywhere between 12 and 16 volts, depending on entire RPM and other electrical load conditions within the vehicle. Buffer amplifier is a relatively low gain amplifier that follows the oscillator. It has a constant input impedance, therefore, it always draws the same amount of current from the oscillator. And this helps to prevent the pulling of the oscillator frequency. The buffer amplifier is needed because of what's happening downstream of the oscillator. Right after this stage is the modulator, because the modulator is a non-linear amplifier. It may not have a constant input resistance, especially when information is passing over it. But since there is a buffer amplifier between the oscillator and the modulator, the oscillator stays a steady load resistance, regardless of what the modulator stage is doing. Then we have the modulator stage. To work, it must have an RF carrier signal and an EF information signal. In a low level transmitter, the power levels are low in the oscillator, buffer, and modulator stages. It may be around 10 megawatt. AF voltage amplifier is another thing. It is highly dependent upon the transmitter's design. The signal level at the output of the AF voltage amplifier is usually at least 1 volt RMS. It's dependent on the transmitter's design. The power levels are quite small at the output of this amplifier, a few megawatt at best. RF power amplifier is normally built with several stages. These stages increase both the current and the voltage of the AM signal. We say that the power amplification occurs when a circuit provides a current gain in order to accurately amplify the tiny AM signal from the modulator. The RF power amplifier stages must be linear. You might recall the amplifiers are divided up into classes according to the conduction angle of the active device unit. Class A and Class B amplifiers is considered to be linear amplifiers, so the RF power amplifier stages will normally be constructed using one or both of these types of amplifiers. Therefore, the signal at test point A looks just like that of test point D. It's just much bigger in voltage and current. Then we have the antenna coupler. The antenna coupler is usually part of the last or final RF power amplifier, and as such is not really a separate active stage. It performs no amplification and has no active devices. It performs two important jobs: impedance matching and filtering. So, working of low level AM transmitter. I explained the working before. Just to summarize it again, let's do it again. So basically there are two signal paths in the transmitter, that is the audio frequency and the radio frequency, AF and RF. The RF signal is created in the RF carrier oscillator. At test point A, the oscillator's output signal is present. The output of the carrier oscillator is a fairly small AC voltage, perhaps 200 to 400 megavolt RMS. The oscillator is a critical stage in any transmitter. It must produce an accurate and steady frequency. You might recall that every radio station is assigned a different carrier frequency. The dial or display of a receiver displays the carrier frequency. If the oscillator drifts off frequency, the receiver will be unable to receive the transmitted signal without being readjusted. Worse yet, if the oscillator drifts onto the frequency being used by another radio station, interference will occur. This is hardly desirable. The linear amplifiers can be Class A, B, or B type amplifiers, the linear amplifiers are used in order to avoid the waveform distortion in AM wave. The low level is transmitter. Transmitter circuit does not require a large AF modulating power, and so its design is very much simplified. However, the overall efficiency is much more lower compared to high level modulation. This is due to the use of less efficient linear amplifiers. So, in brief, the working of an AM transmitter can be explained as, let's say, the audio signal from the output of the microphone is sent to the preamplifier, which boosts the level of the modulating signal. And then the RF oscillator generates the carrier signal. Both the modulator and the carrier signal is sent to the AM modulator. The power amplifier is used to increase the power levels of AM wave, and the wave is finally passed to the antenna to be transmitted. Here we have the low and high level efficiency of transmission. So this is how it's done. We also have an example problem over here to explain the process. That's all. Thank you for giving me this opportunity to present my presentation to you. I hope it was well. Thank you so much.